Hey, it's Mr. Shrum, and welcome back to a lesson tutorial for physiology. Last time we talked about the skeletal system, and now we're going to talk about posture. So right now I'm sitting at a desk and trying to keep a decent posture, but the skeletal system itself allows us to keep a certain posture. And we divide the skeletal system into two areas. We have the appendicular skeleton and the axial skeleton. The appendicular skeleton includes the bones of the arms, legs, shoulder girdle, and the pelvic girdle. There are a total of 126 bones in the appendicular skeleton. And the main function of this part of the skeleton is to attach the limbs to the trunk of the body. Your legs, your arms, those are the appendicular parts of your skeleton. The axial skeleton includes the bones of the head, the vertebral column, so around your spine, the ribs, and the sternum. There are a total of 80 bones. So there's 126 in the appendicular skeleton because there's lots of tiny, tiny ones in your feet and hands, and 80 bones in the axial part of your skeleton, your torso. And the functions of the axial skeleton are to support and protect organs and to provide surface area for the attachment of muscles. Muscles need something to attach to, and that is provided by this skeleton. The vertebral column, also known as the spine, serves as the main support for the body. We have 33 vertebrae in the human spine. The vertebrae are divided into several different sections. The names of the sections are listed from superior to inferior, along with the number of vertebrae in each. 7 cervical, 12 thoracic, 5 lumbar, 5 sacral, fused into one bone, the sacrum. I'm going to go with sacral, and 4 coccygeal, and fused into one bone, that is the coccyx. Yeah. Since the vertebral column is our main support for the body, it determines what movements we are actually able to perform. Exercise is important for the proper alignment of your spine because weak muscles cannot support the spine in proper alignment. So working out or having some type of physical job will help you maintain a proper alignment and keep your spine in check. When properly aligned, your spine has 4 major curvatures: the cervical curve, the thoracic curve, the lumbar curve, and the sacral curve. When you have good posture, the alignment of your spine is correct, and there is a balance of your body segments. Your head is balanced over your shoulders and trunk. Your trunk is balanced over your thighs. Your thighs are balanced over your knees, and your knees are balanced over your feet. So take a look at this person. Her posture alignment looks pretty good. And poor posture habits over the years will cause strain and changes in your postural muscles. And examples of these poor habits and practices include sitting or standing with your back curved or slumped, sleeping on a sagging mattress, insufficient sleep, and chronic fatigue. Those are no bueno. General muscle weakness and tightness due to lack of strengthening and stretching exercises, excess body weight, can not help with posture, and wearing poorly designed shoes, poor mental attitude, lack of self-confidence. Okay, yeah. I guess if you're not looking up straight ahead, shoulders back, and facing the world, I guess that could affect your posture. Yes. So those habits may cause some muscles to lose their tone, while others may become shortened and tight. Eventually, that will result in abnormal, strange curvature in your spine. And common abnormal curves include scoliosis, kyphosis, and lordosis. Scoliosis is when the vertebral column has an abnormal lateral deviation. So it, instead of curving in the normal sense of the word, you have this little side curve and it juts out. So normal and then, and it kind of looks like an S. Yeah. And kyphosis is when the vertebral column has a posterior thoracic curvature. That is sometimes referred to as hunchback. So kyphosis, think of a hunched back, someone hunching over. And then you have lordosis. That is when the vertebral column has an anterior lumbar curvature. This is sometimes referred to as swayback. And if you look at the people, the public, I see this one fairly often. Scoliosis is hard to just tell, but you see some older people with more of a hunchback kyphosis. But I see a lot of people with this sway back where their spine kind of moves in and then juts out near their buttocks. And those curves, those abnormal curves, can lead to injuries or chronic pain if the alignment is not restored. So in order to have proper alignment, that individual may need to strengthen his or her back and their abdominal muscles and improve his or her hip and neck flexibility. It's all very systematic. So you need to take care of your whole body to really have the most proper alignment and posture. All right. So that's the end of that lesson. Let's see. Let's move on to bone formation and remodeling. Sure. Bone formation and remodeling. So we've looked at how bones have important functions in the human body, and they begin to develop in the womb and continue to change and adapt throughout our entire lifespan. Here's some x-rays. I've had my x-ray taken a few times. Bone formation, also called osteogenesis. Osteo means bone, genesis, beginning. So this is bone beginning, or the beginning of bone. And that is what we say is the development of bone. A fetus begins to develop bone when it is 13 to 15 weeks old. So between 3 and 4 months, that is when bones begin to form. The skeleton continues to grow throughout childhood and adolescence. Bone remodeling is the process of replacing old bone with new bone. Bone remodeling is essential for shaping the skeleton and repairing bone fractures. So here you see a repair of fractures, hematoma formation, fibrocartilaginous callus formation, bony callus formation, bone remodeling. And it's really cool how this happens. Bone is composed of 3 different types of cells. You have osteocytes, osteoblasts, and osteoclasts. Osteocytes are mature bone cells, and they are primarily made up of osteocytes. And these guys are responsible for maintaining bone. They help to control homeostasis by ensuring the correct oxygen and mineral levels in the bone. Osteoblasts are the bone forming cells located on the outer surface of bone. Osteoblasts are responsible for producing new bone. And a way to remember this is osteoblasts with a B, build B, new bone. So osteoblasts build new bone. And using collagen and non-collagenous protein, osteoblasts form osteoids. Osteoblasts then create a site surrounding the osteoid for calcium and phosphate to be deposited. This then results in crystals of bone material forming and mineralizing the osteoid. The mineralized osteoid is now new bone. Osteoclasts are responsible for breaking down old bone, which is known as resorption. Osteoclasts are found on the outer surface of bone. Osteoclasts secrete an enzyme which breaks down bone. Osteogenesis, or bone formation, is generated by two different processes: intramembranous ossification, endochondral ossification. And to look at those, we have first intramembranous ossification. This results in flat bones. Think of your skull, your clavicle, your mandible, your jaw, and intramembranous ossification derives from membranes of connective tissue being replaced with bone tissue. And I'll stop there. Oh, see you guys next time.